much for inviting me. After the brilliant optimism and rethinking of your previous session, this is going to be a fantastic way to expand on those ideas. We're going to start with Hedwig Heinsman. She's the co-founder of the US Architects and College. I will leave her to explain her work. She will do it better than me.
We make what we call public architecture. We think that architects really have a social responsibility as designers for the public domain. And therefore we also have a manifesto for public architecture. And I can't really go through all 20 items in the upcoming 10 minutes, but the first one I really want to share with you. Let's do. We love to do, we love to act, we love to engage ourselves with the public domain. Like this one time when we hijacked a lamppost and we handed out flyers. And then we had a temporary public pavilion in the middle of winter time. And suddenly also a very large illegal street party with over more than 300 people attending. And I think that this really shows the power of architecture because you really can create places for people to meet. It also shows the power of design aesthetics, I guess, because this project was totally illegal. And the police were applied about 7 times, because it's also nice. They assumed we had a permit. But it didn't stand itself, and this is, of course, we wanted to refer to the work of the great Marcus Fuller. A really brilliant man with very thought-provoking ideas on sustainability, the well-being of the world, global networks. But how to address this with very limited means. And here, there's a new public domain, the internet came into play. Because people started to blog about this project, to tweet about it. And suddenly, a global community could become a part of this very local event. And it's this interplay between the physical public domain and the virtual public domain that I'm really fascinated by, whether it's related to a very small temporary pavilion or a very large transformation, let's say 1,500 homes within the existing city. Our office doesn't so much design top-down or bottom-up, but we more design the process of transformation with all the stakeholders involved. And as a result, people are much more likely to be committed to their surroundings and therefore also take more pride and care in the public domain. So this is the type of work that we do. And already for a while I was thinking, what could really be the next step in this? How could we really create or engage citizens with city making? And we already had an Ultimaker, a small 3D printer in the office for a while. Ultimaker is a firm that makes these tabletop 3D printers, and they're actually very well connected to a global community of, let's say, amateur experts who constantly work with these printers, share the knowledge online. So basically, there's a global R&D department related to Ultimaker. We thought that this was really interesting, and it wasn't for long until we thought, what would this actually mean for city making? What would this actually mean for architecture? Or what if we actually could 3D print buildings? And yeah, then we really became super excited. Just imagine, suddenly again we really could create unique, personalized architecture at the costs of mass-produced, standardized housing. We could transform waste material into printable material. We could really produce locally without transportation costs, perhaps offering solutions to the growing number of global citizens. And also, all our architecture will be talking in fantasies of the 60s and 70s of the truly dynamic city that we come to being. And we could do all this out in the open, in the public domain, for everyone to see. So this is what we did. We designed a portable, large-scale printer, and we approached Ultimaker, we knew a little bit, and we said, can you help us build this? And they said, well, sure, we'll help you. I don't think they thought we'd really do it, but if you guys will work. So we did, and we found a local contractor to help us out. We stripped the container to the core, and then we totally reworked it. And then about a year later, we had a printer. As you can see, it's really easily transportable. And then we landed on site. This is the front garden of our office. That's where it stands till now, really in the public domain for everyone to see and come and learn. And this is how it works. So we have a print bed of about 2 by 2 by 3.5 meters, and we have a control room in the top. And then basically any type of 3D design you can bring to the computer, Then the designer slices in G-code, which is then sent to the extruder, where plastic pellets are melted to about 220 degrees, which then goes via a hot tube to a printer head, which then is attached to a moving XYZ frame, which prints layer by layer. This is a movie, it's actually a rather old movie, well, as you can see, there's still some manual aspects to the printer. At the time, this is I think taken almost a year ago, we were still printing with a self-built printer head and self-made extruder. But by now we have a really advanced extruder and we can do really quite high detail and fast printing. But that's also how this project developed. It was really a sort of growing snowball betapreneurial project. So we started with Ultimaker, but then more and more people from different disciplines and different backgrounds became very enthusiastic and they decided to join in. And the nice thing is that this year, this number of partners is growing and it's becoming more serious. And the project is also becoming more serious. And that also means that now we can really deal with serious issues. And, well, in our case, I'm from Amsterdam, so we look at Amsterdam. And this is how probably you all know the city. But actually, in the heydays of Amsterdam innovation, 400 years ago, the canal was built. And although this is sort of 400 years ago, still this is now how most of us perceive the city. There's very much emphasis on the historical city centre, and actually the northern part of the city is rather forgotten about. And we think it's very important to not only look backwards, but to also really look at the future of city making, and really think of how we again can innovate the city. And that's why we propose basically a new canal belt for innovation, the northern canal belt. And with that, we're going to start 3D printing a canal house. Actually, we've started already on the north side of the River Eye. Well, a canal house, obviously, because it's really iconic for Amsterdam. Its facade is super lavishly ornamented. It really tells a personal story about the house. But moreover, what is so interesting is that traditionally the canal house really catered for all kinds of different functions. So it was really a place for innovation. You could have a shop there was trade there, you could have an office there, a workshop, you could store things there, you could live there. And all these functions we will now bring again to the canal house of the future. We will print the house room by room, and each room is related to a specific research theme. For instance, we will have the recycle room, or we will have the workshop room. Sorry. So at this moment, we are building a construction site. This is also not really your average construction site. It will be more kind of an open source exhibition site where people can come in, learn, experience, and share ideas. And the nice thing here is actually the relationship between the prepping of the actual construction site that we're doing right now and the prepping of the model. We're scripting the house on the computer. And then we constantly also are beta testing here. So we make prints with a small printer, then we improve the file, we print it again until it's optimized. And the nice thing is that the file that you send to the small printer is actually exactly the same file as that you send to the big printer. So this is how we're printing right now. The entire facade and the first room consist of about, I think, 54 unique elements, a bit Lego-like, that all come together like an intricate structure. And these elements, they all consist of really one piece. So they consist of an interior surface, an internal structure, and an exterior facade. And when they come together, there's a lot of things to tell about the structure, but of course there's space for darts, wires, piping, etc. But it's also engineered in such that when they come together, they actually make kind of diagonal truss-like structures, so that actually the whole house is really structurally sound. So at the moment we're doing all kinds of tests with different materials, different splinter speeds, also different designs, and this is basically one ongoing iterative process where we test melting, the fluidity of the material, structural ability, strength, and this is what I really wanted to show. Right now, we're doing this test print still in our front garden, but by the end of this year, we open the construction site and we really start building the house. And I really want to welcome you all to come help and build us and continue the project. Thank you.
Absolutely fascinating. Thank you very much, Hedwig. And Skylar is going to join us back on stage now, and Rachel Armstrong. Rachel is co-director of the Avatar Project at the University of Greenwich, and Skylar, you probably heard from this morning. Thank you very much for coming on, everybody. Absolutely fascinating stuff. Just to start, it seems that readily very easy to build on the spot, prefabricated, although that is very fashionable now in England, certainly. That would have obvious implications for a disaster zone, for example, but your building is bigger than that, isn't it?
Yeah, what I think is so interesting, at one moment you just imagine that you can have these prints all around the world, and really you can respond to the global context, or local context, I mean. So, maybe, in other parts of the world we print with soil, or we print with materials we don't know about yet. So what I like about it is that it actually, again, contextualizes architecture. And of course, it's not my fetish to build panel houses, but we really thought about this carefully and thought, what's really Amsterdam, and what is really important here, and that's why we're now an architect's version of the house. So of course, it would have been songs in India, it would have been very
And Rachel, your work is just as immersive and brilliant, slightly different sphere. Give us an overview of synthetic soil. I suppose a nice segue into this is the fact that in the square miles of London we have most of it is concrete, is over. We don't really see the soil.
I mean, essentially, all cities are founded on soils. And you think of Mesopotamia, you think of Britain, you think of Venice, you think of New York, and we need rich soils that are normally found within deltas. And essentially, that is the beginning of a civilization. We can plant crops, we can start to have market economies, we can start to develop technologies and, more sophisticated methods of culture. And we seem to forget the roots of where we come from. And essentially, we're robbing our soils, and we're not replenishing them. And the surface area of the Earth, as covered by cities, that I think is 2.5% of the land surface is cities, and actually 3.5% is fertile soils. So if our cities became soil-producing systems, then we'd actually start to replenish the Earth that are processing our existence. And so the idea of a living city or a city that is formed from synthetic soil is really looking at bioprocessing, looking at non-living systems within our cities. And that's why I think the 3D printing movement, providing it's just not dumping a load of plastic in our cities, which you said we talked about in printing the soils, is a very interesting technology that helps us maybe start to process through bacteria and microorganisms, the materials that we have, and recycle them back into substrates that we can then use. So, for example, a building would have soil-producing systems, which might be algae within our windows, biofacades, or there may be anaerobic digesters in cavity wall spaces. We've got very under-imagined spaces within our cities, and maybe these are the sites of novel architectural organs that start to digest our waste instead of throwing it into partly decomposting trash heaps that go nowhere, and then we expect all this stuff to go away somewhere in our existence. I think Mitchell Joaquin talks about the city of New York producing enough rubbish to have a Statue of Liberty every hour. I mean, if all of that could be reconverted and processed back into soils and basic elements, then we're starting to remanage our city. So I think that the 3D printing is actually part of a system of processing that I think that we're really going to have to embrace big time over the 21st century.
Skylar, where does the work that you're doing sit between these two ideas self-building compounds, which are organocarbons, synthetics. Describe that a bit more. How does that link into reimagining really how we construct buildings?
Yeah, the 4D printing work that we did is obviously a synthetic system, and so it's made with polymers, and one of those polymers expands. And so it's trying to bring the argument that the materials we print aren't static, they're not dead, but rather we can activate them or kind of enhance their capabilities after they're printed. So, I mean, one way you can take that is that they can perform as the environment's changing, as the use is changing, they can perform. I mean, the other aspect of it could be challenging the notion that we need a machine bigger than the things we always want to print, which is one major hurdle on the architecture side. And so if we can produce parts that are printed small and then become larger, that might be one opportunity.
What are the environmental implications then? We just mentioned hopefully building everything up. Stop doing that. So, are we talking about the end of manufacturing, or are we just shifted manufacturing into much smaller sections, which isn't as needed? Anyone?
Yes. Well, I think that for me, I have a lot of faith in the maker movement and distributed forms of producing things. Again, so in some ways that using local resources and using local skills and actually being very environmental context sensitive. I think that these really are going to define the manufacturing processes. So it's not going to completely obliterate the need for central systems. But I think that this is the way that we will get major transitions. For example, the infrastructure of water is prehistoric in cities. There's a lovely article in the Atlantic the other week, which was about why is our innovation in water infrastructure so dire. It is dire. I mean, we build drains, we don't build circulations, and water is an extremely precious resource. So the question becomes, well, how the hell do we change that? Well, we change it locally. We can build panels maybe the size of windows that have microfluidics in it. Maybe they have bioprocessing units that are starting to filter grey water within our houses. Maybe we can start to link these up as collectives, and then we start having water orders within certain areas of the city, rather than having to reinvent an entire centralised water system. So I think that the manufacturing processes will go hand in hand with infrastructural changes. And Kevin talks about that. Is what technology wants. That you get patches of innovation locally happening, and there's a paradigm shift. Because all these other parts of vision still in place. So I think that's what's going to be happening.
Where does the momentum come from in rethinking our infrastructure, which is key to lots of these changes taking place? Well, in the UK, we're still largely dependent on the Victorian infrastructure, from sewers to train stations to does this have to be one we've got owned national infrastructure? Where does the momentum come? Is it down to private industry? Is it down to innovators? How's this magic going to happen?
Vision. And I think that when governments just invest in a technology, that synthetic biology, well, it's but to do what? To stick it back within traditional manufacturing processes and have it stuck like yeast inside a big brewery, or to have a vision where people are actually re-empowered in terms of manufacturing organically, with their own little bacterial units, or a home brewing system. Maybe they're making high-value compounds in their basements. Maybe they're trading them with their neighbours. What is the vision in which our technology makes any sense at all? And I think that's what gets people fired up. I think a vision where we're simply just being told to consume less and turn the lights off and do without, that doesn't get anybody out of bed in the morning. I mean, we really do need people that are coming forward with projects that don't seem feasible right now, like living cities perhaps. But something that we work towards, and we heard about the space program right at the beginning of the event here. And it's things like that. JFK did not know how we were going to get to the moon, but he said we were going there anyway. That's what we need.
No, okay, no small amount of vision, which is great stuff. Skylar, how are consumers first going to notice these changes? And very interesting prototypes and experiments in a scientific or a relatively small scale commercial environment are one thing. Are we talking, what's the time scale? Are we talking 10, 20 years before consumers really see a tangible shift in the way that they live?
Yeah, I run a research lab, so our goal is really to demonstrate these technologies and invent new technologies, and the way for us to get them out of academia is to collaborate with key industry partners. And so part of it, is how do we collaborate and find industry partners that have the vision to implement them soon. And so it depends on what scale you're talking about. We can see them in products sometime soon, and replacing sensors, let's say, or making more adaptable products, shoes, sportswear, garments, those kind of systems. If you're saying much broader, like very every product, or they're really completely changing manufacturing as a whole, that obviously takes much longer and they never get there. And may just be an alternative vision for how we produce things or how smart materials can be. But there's nothing really holding it back from these technologies being implemented in very specific products in the near future.
Can you expand on that lovely point you made about at the moment we're a little constrained by having to have a machine bigger than the thing we're trying to build? What are the solutions to that?
I mean, it's kind of a classic paradox that I guess, at least in the architectural world we know of, it's like if you want to build a skyscraper, you don't want to have to build a previous skyscraper to build the second one. Because you might as well stop at the first one. So there's this problem with scale up that if you want to really build large scale stuff, there's a point where it needs to be more distributed, at least in my perspective, and it can't be this top-down mentality. So we need to find ways to work with machines, work with people and materials, and kind of lose control in a sense, but hand over to these kind of simple distributed systems that can achieve much more than some of those products.
What are some of the myths, the kind of speculation about 3D printing that you want to dispel? And you obviously interacted with the public quite intensively. What is the reaction?
Well, the funny thing is, of course, the technique that we showed here is really old already. So this is really not new. It's basically just kind of a glue gun, but what we noticed here is that this technique, although now it's being shown a lot lately, but it's still very much kept behind closed doors. And that's what's actually really fascinating about this project, because we said we're just going to do it, we're going to try it. And more partners jump in, and actually also the fantasies that we have. These utopic ideas of, for instance, reconstructing a new canvas, which is something that we've been doing about for ages. Actually might become reality because of the fact that partners larger than us, really big multinationals, actually also started to jump in. So maybe it doesn't really get into the story about 3D printing, but it does, I think, show about, I think it's more related to the earlier question about who's going to make the difference, and I think it's really, everyone can do this. And I think it's also really nice that actually also a lot of companies have to really rethink the way of working and also collaborate with much smaller enterprises.
You say that 3D printing is old hats now, but I want to think of my mum. It's very much not something that she has got her head around in any way. What is it going to take for 3D printing? Maybe some kind of app store, what's the point at which the potential of a technology becomes accessible and understandable and mainstream? It's not enough to capture the imagination of what somebody can do by printing out themselves. There has to be a functional purpose, isn't it?
Yeah. Well, it's very hard for me to answer because I'm really so entangled with this that for me it's really so mainstream. But I think, at least in the Netherlands, I know, for example, for instance, people who, let's say, sort of timeshare their own home printer. So it's already become very common ground that people just print objects for each other.
Common ground among early adopters, maybe.
But you can also look at it as kind of two sides. One is how do we make it more ubiquitous so everyone knows it. The other one is how do you make it really influential in industrial processes and manufacturing. And it points to the hurdles problem. And what are the hurdles? The speed, the bed size and scalability, actual material properties, not just kind of crappy plastics, but really structural materials that we can use in aerospace, automotive, and smarter materials. So there's kind of two challenges there. People and ubiquitous and industry.
It's an enormous challenge to sort of ask these brilliant people to describe the future in 15 minutes. I think it's grossly unfair. But if I could really put you on the spot, in 10 years' time, if you think back to this time, you think, oh, I remember that beautiful church in London. I was asked, how are consumers really going to notice how they're going to feel this technology? So it will be very hot and it will be mainstream in 10 years' time. How will the products that you're working on be part of our lives in 2023?
I think that in a practical way, we really 3D print bathrooms, for instance, in existing buildings. We have really got like hotel agencies who are very interested in this. You just scan a space, and then you don't have to measure everything. You just press the button, and you have a small nice print. It makes it really cool. But I also think that what is very interesting is in relation to what you were talking about, that this is very much sort of a stepping stone to really self-sustainable, smaller pieces, smaller architecture that really integrate the city. And I'm personally very excited about that. So that I think the whole idea of a living city will really come into being, and you will have maybe also just architecture that's only there for a year, or for half a year, or maybe just for a day. If you have a festival and you bring the biodegradable super nice festival tent, and then after 2 days it rains and it just evaporates. And I think so the city will become much more dynamic. And I really think that can already be the case 10 years from now.
That's really interesting. That's moving away from the kind of, was it archigram in the 60s, the kind of, the building, the city is a machine, and the house is a machine. Actually moving to something much more kind of natural. Simon,
I think my vision is to find a way to change the intuition of how we make things. So open up this possibility in this world of non-intuitive phenomena that are happening that we just don't necessarily grasp, or they're not in our back pocket when we say, okay, I want to build X, Y, and Z, I want to mass produce this. And so if we can change that intuition and open up a whole new space for innovation and making, I think that's where it goes. And it's about physical meeting digital, and synthetic meaning organic, and kind of all of those blending together.
And it's technology is only 50% of the challenge, isn't it? It's actually changing consumer perception. And I hate the word consumer, but people, the public, citizens. It's building understanding and open-mindedness. That's great stuff. So create an appetite for it. Rachel, your vision.
Well, I think in 10 years' time, maybe you won't think twice about what you're making big cake or doing something in the kitchen. You also hit the print button and print yourself a new album and it just keeps you entertained and gives you a little bit of order to do something.
Beautiful. Fantastic stuff. Thank you very much, everybody. And sorry for dropping the mic so many times.